So now we're going to have a look at another example from the topic of electricity and magnetism. So here we have a circuit example. We're asked in the following circuit, find the current through each of the resistors. So we're told this has a 12-volt battery and it has 3 resistors in parallel, one with a resistance of 2 ohms, one with a resistance of 5 ohms, one with a resistance of 10 ohms. So we have to find the current through each of the resistors. Now, in a question like this, we know that resistance is equal to voltage divided by current, and this implies that current is equal to voltage divided by resistance. So there's a few different ways we could do this. Some of them are fairly long, some of them are fairly short. In a parallel circuit, we know the voltage is actually going to be the same across every resistor. So this is a known rule for parallel circuits of this variety. The voltage is the same everywhere, but the current changes. We can use the fact that the voltage is the same everywhere and that these resistors have different resistances in order to find each of the currents across each of the resistors. So for resistor 1, the current is going to be 12 divided by 2. So this is going to be 6 amps. For resistor 2, we are going to have the current is 12 divided by 5. So if we decimal approximate this, 12 divided by 5 should give us 2.4 amps. And for resistance 3, we have the current is going to be 12 over 10, and this will be half of resistance 2. This will be 1.2 amps. And so these are actually our 3 answers. 6, 2.4, 1.2. 6 plus 2.4 is 8.4, plus 1.2 is 9.6. So we have a sum which is equal to 9.6 amps. Now one thing that we might choose to do in this question is we might choose to confirm this. We can reduce this circuit to a circuit, a 12-volt circuit, which contains a single equivalent resistor. Now the resistance here, resistance total, we can calculate using our parallel resistor formula, which is 1 on RT is 1 on R1 plus 1 on R2 plus 1 on R3. So we can plug everything in. We get 1 on the resistance total is 1 on 2 plus 1 on 5 plus 1 on 10. You add all these together, this tells us 1 on RT is 0.8. When you solve this, it tells you that the total resistance, the equivalent resistance, RT is going to be 1.25 ohms. And now we know from above R is VI, R is V over I, and this implies I is V on R. So the current in this single circuit, in this single resistor circuit, should be 12 over 1.25. Now 12 divided by 1.25 gives us 9.6. 9.6 amps. This is the sum of the currents that we got when we did the currents individually. So this essentially confirms for us, this is a check that we can do, this confirms for us that the answer that we have above is likely to be correct. And in fact it is correct.